Okay, hi everyone. So my name is Pauline. I've been working for FarmWise for about 4 years. It doesn't sound like a lot, but in the history of a startup company, it is a lot. And I came in as the first non-engineer hire on the team. So I've been wearing a lot of hats over the years, from helping the company raise funds to developing product strategies and proper business development, talking to growers. I was in the Midwest last week, so like there's a lot of grower interaction happening on the day-to-day for me, and so really happy to be here. So I guess I'm representing kind of the industry here and more like the technology side of things. So the way I want to go about it today is to kind of give you an overview of what we do and hopefully share some videos so you have a good sense of what the equipment does. And I can talk a little bit about what the status quo used to be and how, automation is changing certain processes in the vegetable space in particular. And then also discuss differences in performance and maybe some topics related to ergonomics and safety. We're obviously not safety expert, but I can talk to you about how our employees who are operating the equipment interact with it and how do we make sure that they're safe. Um, I don't know how. There you go. All right. So FarmWise exists or is in business today to help growers with the fact that the resources they've been relying on for decades are shortening, and under resources you can put field workers, farm labor, and you can also put chemical usage. So maybe in the vegetable world we don't talk so much about pesticide application, but fertilizer, for instance, has come increasingly under regulator scrutiny, and how do we optimize our fertility practices, fertility management practices. So we're really here to like help growers transition into an era where resources were abundant and now resources are shifting, so we need to switch gear ourselves. And how do we make sure they're successful from an economic perspective, going through this transition. And so to do that, we leverage sophisticated technologies, things like automation, AI, and robotics. Awesome. And so on the right side of this picture, you can see a typical hen weeder. So how a person would go around the field and hen weed, um, with a hoe on a lettuce field. But we've seen in, if you go in like denser planting situations such as carrots, I've seen people on their hands and knees pulling the weeds with little knives. So it can look like that. It can also look a little bit different. Um, So just to give a little bit of context on the crops I'm referring to today, so leafy greens, brassicas, grown in the Salinas Valley, so coastal region of California, southern deserts. So your lettuce, cauliflower, broccoli, radicchio, cabbage, we could make a great song out of it. These crops are, in terms of weed control, options are quite limited today for growers on the chemical side. If you talk to Bayer and so on, they're very much addressing large acres. And if you take a crop like lettuce, which California is really leading the production, on the lettuce side, like there's an herbicide that's a pre-emergent herbicide called Curb that was registered in '72. There hasn't been a lot of, I'd say, R&D funding into new modes of action discovery programs. And so our growers oftentimes don't have chemical weed control options. You may or may not think it's great, but the result is that weeds needs to be controlled, and they have, again, like limited options there. So the way they would go about it, if we're talking conventional farming, um, actually organic, they can also have access to an herbicide, a pre-emergent one. They would apply that herbicide, then they would resort to cultivation, so drag a cultivator across the field. That cultivator is usually not super smart. It's not camera guided by any means. It really cleans in between the rows, the lines of the crops. And then for that portion that's in between the crop stands, they will have hand weeding crews, so 15 to 25 people walking the field, progressively removing the weeds. They may come in once, two, three times, depending on what the situation is out there, with density. And obviously, there are situations where growers maybe will take over a ranch where weed management wasn't so great over the past few years. And so they have to deal with that kind of seed bank and control it. And that's obviously really tough and increasingly more expensive to do. So what we're seeing, in this market is we have farm labor shortages, competition over labor that is exerting a pressure on prices. And so on top of that, you add California regulating minimum wage and overtime, which is great for those field workers, but who does absorb that kind of difference in cost? And it's usually the growers, not the retailers. So we're ending up in situations where it's not economically feasible or sustainable for growers to manage their weeds. And so when we started the company about 5 years ago, that was looking at, we looked at all the sequence of activities happening on the farm. So Jennifer talked a lot about harvesting, and I think that's a tremendous opportunity for automation. It is also a very complex problem to solve because, harvesting operations change a lot depending on the crops and the cut and the trim. When it comes to weeding, it pretty much looks the same for, I'd say, 70% of those crops that vegetable growers in the Salinas Valley will grow. So we thought, let's start with that. And so again, that's kind of how today the situation looks like. And on the right, you're looking at the machine that we came up with. So this machine was released in 2020, and that's today the machine that we operate commercially. So we've been kind of commercially out there for 3 seasons. We had previous machine that looked a bit different. This is the 3rd iteration, and we're preparing for the next generation that will also look a bit different. But so here, what you're looking at is both a power unit, so your standalone kind of tractor, but cabless. There is no cab in here, and there is nobody sitting in the cab. And then you have the compute power that's concentrated in that kind of number 1, compute power and cameras. So that's where we're looking at the crop. And between the time we're capturing images and number 3, which is when we make a decision on that image, there is about half a second that goes by. So the machine, as it goes through the field, scans the field, look at the crops, make an assessment on where are the crops, and weed the negative space, so to say. So we'll actuate blades, open and close around the crop, and removing everything that's in between the crop stems. We're also cleaning in between the rows using fixed tools that will move with several degrees of freedom. We're also cleaning the furrows and the shoulder of the beds. So really our goal here is to kind of squeeze, automate the hand weeding process and also help with, that cultivation pass that growers will do anyway. So kind of combining, 2 passes in one. And usually we come in once. There's been instances where we come in twice during the season, but that's what we've been doing so far. And we work on 12 different crops today. And so the way our system works, I'll show you a video right after, but the way the journey starts for us always on a new crop is capturing images. So we have, a camera per line of crop that captures images. What we want to see is tons of weeds, tons of complex scenarios. It's like teaching a child how to walk, but here you're teaching a computer how to recognize what is a weed and what is a crop. In our first kind of, I would say, like philosophy is about teaching the computer to recognize what is the crop, what are the edges of the crop, and where is the meristem located. So we're kind of like making an assessment or a judgment call on where the root zone is likely to grow. And that allows us to calibrate the opening and closing of, blades that are actuated by robotic arms really precisely around the crop. And all of that can be tweaked remotely or through a tablet while operating the machines. And yeah, again, today we work on 12 different commodities, and the goal is, to expand that list. The people we work with will grow 10 to 20 different crops. We want to be able to accommodate all of that. Definitely, and like interesting things we've been working on lately are tomatoes, melons, peppers, and I'm a huge fan of sugar beet because I come from Europe and we don't have GMO seeds in Europe, and so what we're seeing is, the spacing and the way the crop looks like, it's very much looks like a leafy green, and I think there's tremendous opportunity here to not use chemicals for weed control in sugar beets if we're able to go faster. But it's my little side projects trying to convince people at FarmWise we should work on sugar beets. I will show you this video so you have a better idea of how the system works and look like. Yeah, I think you can ask your question even if the video is running.
Just a quick question. So, farmers, you said you work in Salinas Valley, are you guys also down in Imperial Valley?
Yes. Yeah, we do quite a bit of work in Imperial Valley, actually. I think it's an interesting situation. I think Yuma feels the farm labor shortage is a bit less because, California is regulating heavily on minimum wage and things like that. So what we're seeing is we truly believe that Yuma is kind of 3 years behind in terms of, I think when we started 3 years ago, the questions we were being asked by growers in terms of performance requirement or excellence requirement were much higher than they are today, which tells us that, they're really in a pickle. And I think Arizona is not there yet. Imperial Valley is a different story. And so last winter, we did a lot of work in Imperial, and we'll, just do the same thing next year as well, or this year rather. Oh yeah, so I'm not sure why Zoom hasn't fixed that, but when you share your screen and share a video, it's not great. But again, like feel free to email me, and I'm happy to share any videos we have publicly available. But that's kind of how the equipment look like in the real world, and not on a PowerPoint presentation. That's the detection in kind of real time. So you see how we like map the outer edges of the leaf, and then I don't know if you were able to see, but there was a little blue dot that's where the computer perceived the stem to be located. That's some cool visual from the robotics planning. And so you can see that the machines is operated by a supervisor. That's a human. It's not a robot. And so this person has a tablet that gives him full control over the equipment. Um, and so this is the motion that you would see out in the field. So that's a very weedy romaine field, lots of purslane. She's, a great succulent, but really, really choking the lettuce. So it needs to be removed. And so you will see here briefly, we have those cultivation tools, standard cultivation tool that moves right and left. That's broccoli. And I love to share that because, 5 years ago, this was not really possible. It's really because we're leveraging AI and artificial intelligence that we're able to do that. You wouldn't be able to do that with typical infrared system, like detecting green on brown or a blob of green, because the stem are really close on broccoli. They're, you're looking at 5 to 6 inches from stem to stem. On lettuce, you're closer to 10. So and especially if you're working on a transplanted lettuce field, it could be easy to kind of set up your system to open and close at like every 12 inches. You really cannot do that on broccoli, and those fields are organic, broccoli and celery. So, the cost of transplanting is really high. And so, crop kills is not an option. Like you cannot touch the crop. So we really made those blades pretty short, and that allows us to really weed in between the broccoli stems. And I think that is probably the end of the video. Yeah, that's a super weedy celery field in the Oxnard Plain, so close to Santa Barbara. They struggle quite a bit with finding labor there, much more than Salinas. All right, so let's go back That's another video, but the complexity of technology will prevent us from looking at it. I think I'll just prevent you from some technical disorder. But we've been, just a quick note on that, we're capturing a lot of data points to do what we do on the field. Stuff like plant counts, size of the crop, stem to stem spacing. And we're also able to kind of detect where a crop should have been and is not. So all of these kind of simple metric, those kind of important metrics we thought was interesting to give back to growers. So we've been piloting this kind of what you could call it kind of grower dashboard platform where we are giving back to to a couple of customers some data here and there and just seeing how they interact with it. I think monetizing ag data and making sure this data has value and that grower can act upon this data is a big challenge, and a lot of companies are trying to make that happen and are not really successful. So it's a tough nut to crack, but it'd be too bad not to give it back to them. So that's what we're playing with these days. That's the video we just looked at. Oops. We talked about that. Yeah, and so I was asked to kind of give you a sense of like, okay, so before this used to be done by humans, and how is it, how does your performance compare to this human today? So a recent example is, so we're compared obviously with human in terms of weeding performance. How good of a weeding job are we doing? How many weeds are we removing? Are we removing more or less? The same amount? Then we're also obviously compared on coverage, like speed. Are we going fast enough? And so the way to look at weeding performance, the way we look at it from our kind of technology standpoint, is the performance of the AI models. So how good is the model at detecting crops? And so whenever we release a model, we never release a model that has below 80% of accurate crop detection. So that means that 80% of the time, the model will successfully recognize that this is a romaine and it's not a lamb's quarter, or it's not, you know, goosefoot nettle. That's one thing. And then we're also looking at what we call crop kills. We used to call them massive killing events. There's a lot of foreigners at the company, and we thought we have to rename that. Branding wise, it's probably not a great name. But so we're also trying, making sure that we're not killing too many crops. That's an obvious statement, but when you develop technology and you run it out in the field, it happens. So we'll have a threshold when the system kind of registers that we've been killing X amount of crops. The machine will stop, and we'll have to do like an evaluation. There's something there's a lot of false positive, and we're struggling with this lens quarter. Maybe we should switch model. Maybe we need to stop at all. Maybe we need to pull out and think about how we will go about that. So there's many things that can be done, but in any case, where we have like crop kills threshold, where we're trying, obviously, to keep this down. So like in terms of speed and like coverage, a good example that I was given by one of our kind of commercial ops people recently was we were able to weed an artichoke field that was about 18 acres in a 10-hour shift with 2 machines, which is really fast and really great. Humans, like a crew of 15 to 25 people, will have needed to be weeding this field for at least 48 hours to get that done. So we're really trying to obviously be competitive and also be as efficient as we can. And so just sidetrack, we are operating a fleet of machines as a service. So we're a custom service provider, the same way growers will call Wilbur Ellis for fertilizer application, spraying application. We're providing a weeding service to them. And so having a fleet allows you to maybe pull out more resources to finish a field, because we have to finish it in 24 hours. But the goal is really to improve that metric over time. And so an acre an hour is kind of like the target goal, I'd say. And that's a little photo of our. So our headquarters are not in San Francisco anymore. We're officially, operating out of Salinas and opening an engineering office in South Bay. But you see how the machines are set up before start of the day, and we have, a fabrication shop technicians that take care of the machine at night, and then we have human operators that, drive with Class A license that drive the truck and the trailer to the field, do the job, and come back. And so these people are equipped with a tablet where they can stop the machine, brake, accelerate, tweak some margins, open and close the blades, faster or slower. They can do a bunch of like tweaking. We also have a remote teleoperations team. So people sitting behind their computer and looking at the performance of the machine at all time. And these people can also stop the machine, tweak certain things from where they are. And in terms of kind of general safety, we have 6 e-stop buttons on the machines, physical buttons, and then the machine can be stopped from the tablet. We don't consider our machine to be autonomous systems, and we actually, I'm really not pursuing that autonomy at the current moment. Now, will every farming machine will be autonomous in the future? Probably, but it's kind of a different problem to be automating a process versus automating the driving, and we choose to focus on the first one because we think this is where the value, the max, the real challenge is at, and the real problem is at currently for farmers. In terms of safety, like one general thing is if the operator was ever 100 feet away from the equipment would stop. We're in compliance with Cal/OSHA regulation, which kind of limits us in ground speed. We can't really go faster than 2.2 miles an hour. We have to have someone, within a certain distance from the equipment. We have to have remote control access and physical, stopping capability on the machine. So we're really following that. And that's California OSHA. Arizona is much more forgiving or relaxed on those requirements. And just to like give you a little bit of preview on the next generation, we're dropping the power unit at the front and really making this implement a simple pullback implement that can be dragged by any kind of industry standard tractor. So that will remove a lot of those requirements that we have to work with today. And happy to expand more on like why I think this regulation needs to change. But today, that's kind of like the framework we're working with. And in the middle here, you can see the dashboard, what our teleoperations team, so people, working remotely, they may be in the physical office in Salinas or at home, and they're watching the machine at all time. And we also have built in-house tools, like software tools, to allow us to do what we do, to like schedule jobs and schedule maintenance, know how a machine needs to be configured, because as you probably know, sometimes you grow 6-line lettuce, sometimes you grow 3-line cauliflower. And so the machine needs to be ready for that physically, hardware wise and software wise. So there needs to be a little bit of pampering the night before. And this is just a snapshot of our team. So we're a startup company funded by venture capital fund. We're also been supported by some strategic investors in the space and tractor manufacturers. And I mentioned Wilbur Ellis. So folks who are really interested in kind of advancing this industry and making sure that growers are, empowered with all the tools they can to do the greatest job possible. And yeah, that'll be it. I'm happy to take any question you may have. Thank you.
So I have a question, like, what's the frequency of weeding in a growing season?
Frequency on weeding from the grower side? Like how often do we need to, okay.
Yeah, with your device, with the machine.
Yeah, so usually like the status quo is growers will, let's say we're talking about conventional romaine that you buy at your supermarket, like the romaine hearts, they'll be weeded probably 2 times. in the season. And with FarmWise, we usually come in once, and that's during the first month. So those croppers are grown between 2 to 3 months from seeding to harvesting, and we'll probably come in 2 to 3 weeks after transplanting, or 3 weeks after directly seeding the crop.
I feel like the device is kind of heavy, and I'm really concerned about like when it does its work, like does it impact the soil profile, like make the soil more compact, so that kind of in long run maybe mess up with the soil profile.
Yeah, so you'd be surprised how much those crops or like those productions are operations heavy. There are a lot of operations, a lot of activities happening during the entire cycle of growth. So like big tractors are dragged across the field many, many times. So it's not so much about heaviness, then it's about pressure. So, the pressure that you apply to the ground. And so we try to stay within what standard tractors are applying to the ground. I do believe there is room and there is a vision that needs to be executed on bringing lighter, smaller machine forms to the field. And I think, that's true for vegetable and that's true for row crops as well. And soil compaction is definitely a concern and something that we want to avoid. But I'd say today we're probably on par with what a tractor will apply to the ground, and those crops are sprayed multiple times during the season, and there are stuff coming in and out of the field. So we're adding on to that. It's true, but I don't think we're by any means extraordinarily heavier or applying exerting a crazy amount of pressure.
Thank you.
Sure.
The device is really cool.
Thank you.
Here. And hopefully
I was just curious how you do the pricing, like how much, I don't know if you could share, but how much does the machine cost? And then I'm just thinking, like, is it 25 people or this many hours for your machine, like how you guys are calculating it, payback period?
Yeah, it's a great question. I forgot to mention that. Okay, so if we pull up a UC Davis cost and return study, like the most updated one dates back from 2019 on romaine hearts. And if you look at the entire weed control program, we're probably close to $400 an acre. And so that's not taking into account, inflation adjustments and rise in minimum wage. And so in that $400 an acre, you count, pre-emergent herbicide application, cultivation, and hand weeding. And hand weeding is probably like $300 an acre out of those 400. We try to be on par with that. And so we don't really disclose prices publicly, but like we operate today in the range of like $200 to $400 an acre for one pass. And there are occurrences where we are being asked to come in twice. So that shows you how it's really hard to give a just kind of one answer of this is what growers are paying today, because it depends so much on the weed density. Is it a conventional or an organic field? What is the soil conditions? Because like we will do, if the bed prep, the land preparation, a lot of effort has been put into that. If people have paved the way for automation to do a good job, like we're gonna do a great job. If the soil conditions are really difficult, like big dirt clods, that starts being hard to open and close blades. So I think there's a lot of factors that goes into fixing the price. It's like we're really trying to be competitive with labor, and that competitiveness comes from obviously being faster or as fast as they can be, and do as good of a job, if not a better job than what they're doing. But this is kind of like the range you should have in mind.
I have a simple question regarding, weeds are very versatile plants. So with the mechanical utility, there must be some rerouting of some of the plants because of the way the soil is covering up some of it. So do you have any data about that? In other words, what you might expect, and if that's a problem, or it must depend on the species, for example, the porch top, or the one you were showing, that would be very more tolerant, I would expect. So some of them probably are easier to kill than others, right? So
Yes, because of the nature, I'd say, of farming around here, there's irrigation happens often, so wheat flushes will occur. And I think because of the cycle is really short, we're not talking about a year or like 9 months of growth. That's not 120-day corn. So what happens oftentimes is that, say, like we're dealing with pretty small weeds. Like again, I said I was in the Midwest last week, and they showed me mare's tail that was like boot high. I had never seen this my entire life in the Salinas Valley. Like your mare's tail will be, close to the ground, and the roots are pretty shallow. So the way the mechanical system works is we're exposing the root to the sun, and because we're in the climate we're in, like they die. Now, to your point, we've never conducted any study on like how much regrows. I would think that the only weed I would imagine would regrow is purslane, because it tends to regrows in everywhere. And I've met with growers, carrot growers, who will have people carrying bags to put the purslane in, but it's not been a request, or it's never been a concern that's been brought up. But it'd been indeed super interesting to like conduct those studies and nerd out on that. Thank you.
Let me just ask a couple of questions that I'm finding online. First, a couple of congratulations, saying that there's a great presentation, really interesting. So with that, and then they have more of a applied question. Does changing light conditions affect the performance of the equipment?
Yeah, it's a great question. So if you see on the videos, we operate under a controlled environment. So we control the light. So we're strobing lights onto the camera. If you happen to rewatch some of the videos I shared today, you'll see there is some kind of like you hopefully nobody's epileptic, because it would cause them disturbance. But so we're strobing light and we're operating under a hood. So it's really dark, and then suddenly we're strobing light. So we have those beautiful images. So like here, it's an example, but we have some really like kind of perfect images of crops and weeds. So that allows to do the job. Now, oftentimes the hood will be open because maybe the operator is a little nervous and he's just started working for FarmWise, and make sure that he's not killing crops, and you want to make sure he's like really aligned with the bed, or and therefore, we control less of the light there, and we haven't seen any issues. So I think there is room to improve lighting conditions in any case in our system, and in every system that's using lights. It's kind of a critical actually dimension. You could have a very powerful camera, but if you're not, using managing light properly, you could probably use it suboptimally. So definitely a lot of work and research that goes into that, making sure we have the right lighting in the right conditions. But we operate throughout the day from dawn to dusk, so we see all kinds of conditions, and that seemed to work out pretty great.
And another question is related to application of the techniques. I know that there's mechanical planters, for example, that are very well established, but the person is asking if you've explored using your techniques, better planting approaches.
So we've not. We've done a lot of like research or like market studies and talked to a lot of growers, and really like what kind of stand out for us and stuff we're pretty passionate about is helping with, Jennifer mentioned those kind of spot spraying or the application of pesticides. So essentially, we're detecting where the crops are. So we're already doing that. So what could we do, based on that? Because right now we're mechanically actuating blades in the ground around those crops, but we could be doing a different actuation, whether it's spraying, injecting fertilizer in a bended way, whether it's selecting a head of lettuce that's mature and ready to be harvested according to the standard we want it to be harvested at. So I think there is plenty of room for automation to optimize or transform the way we do things out in the field today in the vegetable space and in the row crop space. It doesn't mean taking jobs away. It means empowering those people and bringing them into more supervisory position. and paying them more and offering them better working conditions. So haven't done the planting exploration, but we've developed a prototype of a spot spraying just for fun. Haven't really worked on a commercial commercial expansion of that, but we've played around with things, and we'd love to be doing more. Um, but again, like the nature of the company is, we have to remain focused, and it's hard to spread out and do millions of projects. So kind of building really great weeding implements that's reliable yet versatile, modular, able to handle lots of use cases, and easy to use by any kind of tractor driver. We don't want people with technical degree to operate those machines, is a huge challenge in itself and may not look like it, but it is really hard. So that's kind of the focus of the company right now.
Thank you.
I have a couple questions about water. So generally, does the machine require certain hydration of the soil to operate the most efficiently? And do you have to base that off of water schedules that are already determined by the farmer? And then my second question is about like commodities like melons or tomatoes that have drip irrigation. Can you speak to how it works in that situation?
Yep, so we're mostly working with buried drip tape that's like 4 inches below the ground surface, and that's no problem. We really our blades are pretty shallow, like 2 inch, come in 2 inches deep into the ground. So we're really working, obviously you don't want to knock the drip tape, so that's what we're working on, and primarily what we're working with. Now, in terms of moisture, it's more about, making sure we're able to enter the field, because oftentimes if the irrigation is turned on, the field remains wet and actually no machinery can come in, or, we don't want to disturb the bed. Like, we want to have the most perfect bed, to make harvest as easy as possible. So you don't want to come in when it's wet. So it's about kind of timing it correctly, and that takes a lot of communication with the growers. So I think that's the hard part, is making sure that we're entering at the right time and at the right window where the weeds are emerging. So it's more about timing ourselves with the irrigation schedule, than like us needing certain conditions. I think the same condition applies for every piece of tractor that needs to go into the field. The field needs to be pretty dry. It doesn't need to be extremely dry, but you need to be able to run tires there.